Good morning. Morning, Dr. Sonali. Your voice is not heard.
I'm talking to Prof. Mukhtar.
Yes. Morning. How are you?
Morning, morning. How are you?
I'm fine.
Are you also from Duhok?
No, I am from Baghdad.
I'm not seeing all the panel members, so let's wait a bit.
Yes, I can see them here.
I can only see others. One other. Like, no, it's just you and me. We are waiting for 3 other people.
I see Dr. Berivan Hadi. He is also with us.
Who?
Berivan Hadi.
Yeah, but Dr. Hadi is not a speaker, right?
Dr. Hadi, yeah, probably. He is on the panel list.
Yeah, I'm just worried about the 5 people who will be talking in the session.
Okay.
At this point.
Yes.
Okay, but let's wait. We have time. We have 3 more minutes, and then I'm sure the organizers will help us. Okay. Dr. Makram.
Yes,
Hello?
good morning.
Yes, just a quick question. Do you want to be addressed as Dr. Makram or Dr. Harzali?
It's the same for both. Harzali is my family
What is
name.
your first name and what is your family name?
My first name is Makram and my family name is Harzali.
Okay, so I'm going to address you as Dr. Harzali.
Okay, no problem.
Yeah.
Good morning, everyone.
Good morning.
Hi. Morning.
For the late attendance. Dr. Omar Ghazal, the other panelist. I think
Yes, what I am
the other
seeing
moderator.
is I am only seeing 3 speakers so far. I'm still waiting for Dr. Pati and Sukina.
I think Dr. Pati just came in, Dr. Kafi.
Okay, perfect. So only Sukina is who we are waiting for.
Okay.
Good morning, everyone.
Morning,
Good morning, Dr.
How are
Kafi.
you?
Hi.
Morning.
So Dr. Harzali, what time is it in Tunisia now?
It's 8 morning.
Okay, so you are 1 hour behind our time, and then the
2
sessions are 1 hour
hours.
ahead.
2 hours, yes.
2 hours, actually.
Yeah.
What is the time? Is it 7 o'clock?
No, it's 10 o'clock in Iraq.
No, but in Tunisia, what's
It's
the time?
8.
8, exactly. So we are in Johannesburg, so Tunisia is 1 hour behind.
Yeah.
So I'm just waiting for Sukina, and we still have 2 minutes.
So, Professor Das, are you the other moderator?
Yes.
Okay, nice to meet you. Are you going to present the first speaker?
Yes, so I'm thinking that let us go through, so let me take through all the speakers, and then if you can manage all the question answers and the time. Are you
Okay.
fine with that? How would you
Totally-
like to?
Totally fine. Totally fine with that. Yeah.
So I can introduce the speakers and I can go through it, but if you can help with, controlling questions, if any. Do you
Okay.
want questions after every talk? So we can do a 15 minutes talk time and a say 3-minute question answer buffer time,
Okay. Okay, that's cool.
right? And
That's
then if
okay.
people have any overall questions and if we still have time at the end, we can allow that.
Sure. Sure thing. Okay. Please do that.
Okay. So Sukina has just WhatsApped me to say she is on her way to join. So let us give 3 minutes before to start. So then we start at 9:05 if that's okay with Dr. Hadi.
I think it's okay. If Dr. Makram is ready now, we can start now. If
I'm
you'd like
saying
to.
I just contacted Sukina and she says she is going to be online now. She's still driving, so we don't want her to get into an accident.
No, no.
So do you think we must start in the interest of time?
I think
we
if
have to
Dr.
start right now.
if Professor Makram is already there, so that we can start.
Okay.
So I am the first speaker.
Oh, sorry.
You will be the first speaker. Okay.
Yeah.
Of course,
Yes.
Professor Das. Okay.
Yes, so I'm the first speaker, then we follow it with Dr. Harzali. Then we wait for Sukina to park safely and be ready. Then we have Professor Al-Mukhtar, and then we have Dr. Pati. And we will have 15 minutes of talk time. And I'm not sure with the audio, usually it's good if everybody else keeps their audio mute, because often we have the echo feedback that comes. So if all non-speakers can please put their audio on mute. The way we want to operate is we will give a maximum of 15 minutes talk time with a 3-minute question answer time. If there are any, which will also give the next speaker time to get ready with their presentation. If there is time at the end, we will take questions from the panel and attendees. I see we have 26 attendees, which is great news. So I will take the liberty to start. So you are in technical session 7, which is engineering, technology, and computers. And I was going through the biographies of the speakers, and all of them seem very interdisciplinary and very practical research oriented. So that's, I think, very relatable, especially with younger students who often don't have the luxury to see where their academic learning fits in the bigger scheme of, you know, job satisfaction, finding impact of their work, etc. So I will take liberty to start now. It is 9:05, so by 9:20, I hope the other moderator can warn me. And I will take you briefly through who I am. My name is Sonali Das. I am originally from India. I did my bachelor's and master's from India, and after a period of about 4 or 5 years where I was in industry, or I shouldn't say industry, I was not actively pursuing a PhD. It gave me enough time to reorganize what I would like in life, whether I'm happy with what I'm doing or would I want to challenge myself further. So in 2001, I went to the US to do a PhD in statistics. And I'm so happy to see that there is another pure statistician at the end of this session. So we start with a statistician, we end with a statistician. After my PhD in the US, I came to South Africa in 2006. And for about 13 years thereafter, I was working at the Council for Scientific and Industrial Research in South Africa, and had the wonderful opportunity to test out my own competence as a statistician in application, and work with wonderful domain experts, and which opened up my eyes into real world problems beyond what we may learn in a subject of statistics, where we are polishing our tools, but don't often have the opportunity to use them in a variety of fields. Let me open my slides. Share screen. Moderator, can please tell me if you can see my screen? Can you see my screen? Amal, can you see my screen? Hello?
It was okay, but now
Is it gone?
It appeared, but now no.
Okay, let me share again.
okay, just share it.
Just a minute. So give me a little more time. Is my screen visible?
Now it's okay, yeah.
Okay. I did see Amal briefly. Amal, are you still here? Okay, never mind. So let me.
Lovely morning, Sunan.
Yes.
Yeah,
No, I'm
nice
so happy
session.
to see you.
Nice session, inshallah. Nice session.
Okay.
Good luck.
So we are starting the session, and as promised, the talk title is what you see on the screen. So after my time at the CSIR, I joined the University of Pretoria, not the statistics department, but the business management department, because after my about 12 to 13 years at the CSIR, working with a lot of interdisciplinary people, it was very obvious for me to branch out in areas now where there is opportunity to bring in statistical thinking into risk management. And when I say risk management, it is such a broad term that you can use it for any aspect of decision making, any aspect of business decisions. Business decisions impact everybody, everybody's decisions impact business decisions. So it is a, continuous loop within the ecosystem of business, humanity, environment, and anything that comes in between. So before I start, I think when Amal invites, we go back to memories. And thank you, Amal, for wonderful memories that we have connected to the conference. Right from the one in 2017, where I met Amal, and also I think in our lives when we are busy doing what we are expected to do. Sukina, welcome.
Thank you. Good morning, everybody.
But we are in the middle of a session, so we can't talk much. So I was telling that these memories are important because these act as boosters, in how we operate. Sometimes we are so preoccupied in our own ecosystem, which is teaching students, our own immediate research. When you step back and revive these memories, it's very important to see where do we fit in the bigger scheme of things. Are we identifying correct problems? Are those problems being identified by the right people who are being affected by those problems? And it's not about women, man, equality. It is every space has problems. Every space, the problem affects people who live there or who are exposed to those problems differently. If we don't hear those voices and concerns, the solutions obviously will fall short of intentions. We lose important, time, resource, opportunity. We don't want to be there. We are wise enough now to say it has to be inclusive conversation so that the solutions are more effective. So yes, in 2017, I met Amal for the first time, opened up my mind to the wonderful world and space of interdisciplinary research. And I have to say women in science, because we don't explicitly always engage in those forums. In 2018, we had the conference in Johannesburg, and this is one of my bragging points because the 2018 conference, some aspect of it was published in the South African Journal of Science. And if you see carefully, I'm on the front cover of a leading magazine. So yes, I treat it as my celebrity moment. 2019, we had it in Cairo. Again, a wonderful conference. And I'm so sad that before COVID, when we knew the conference was going to be in Iraq, I was so excited to have the opportunity to come to Iraq, which hasn't happened, but we will do it again. Okay. So why am I analyzing, or why do I want to study spatiotemporal weather data, right? It is a recurrent problem across the world, and especially where we sit in Africa, and especially where we sit in South Africa. And if you have not heard of the ACHI biodiversity targets, well, today you can take that as one of your learnings from this talk. It basically reiterates that we should never stop talking about or researching on aspects of biodiversity and the changes that are going on, and how to contribute from our own fields into this discussion of the crisis in the biodiversity. We are all aware of it, even if we don't actively do that research, right? And this paper is really hot off the press, right? It talks about biodiversity and ecosystem services on the African continent, what is changing and what are our options. And when I see as a statistician this talk or this paper's title, I say, what is changing? How do we define change empirically? And how do we quantify change empirically, right? So for me, I always see problems through the lens of my own training. And it fits very well into what I have been doing for many years as an application area, and also from the domain of statistics, which is functional data analysis. So by studying climatic measurements, we can obviously hope to better understand what is changing, where is it changing, so that if interventions are to be targeted, are we going to the right places with the limited resources? Okay, so as a statistician, the questions are, how must we do this kind of research? Obviously with data and obviously through models. And most importantly, by going back and forth with our results and findings with those who are experts in the domain. And here it is more weather researchers or climate experts. So last year we published a work from one of our students who did her master's. We took data from South Africa. So you see at the bottom here, we have the map of South Africa. We tried to pick locations of prominent cities or popular destinations. So because this is south of the continent, obviously all this is sea. So this is the coastal region, and then we have a number of inland regions. Okay. So these you will see are the locations, 16 locations we investigated, and we wanted to study 40 years of data. Now the data was hourly data, so it's a lot of data, right? Sorry, it was not hourly data, it was daily maximum temperature, daily minimum temperature, daily rainfall, daily humidity, wind, etc. It was a huge amount of data, and we were not in a position at that time within the scope of the masters to use all that data. So we made a decision that let's focus on temperature, and then let us only focus on every 5 years of data. So yes, 40 years of data, but every 5 years. So we started 1965, then 1970, 1975 up until 2010. Okay. So if you give the data to a student, the first thing they will do is run through summary statistics, right? The table that you see doesn't have any timestamp in it. So all that data dump into your summary statistic procedure, and this is what you get. It gives us a profile of, which are the hottest regions, which are the cooler region among the 16, etc. So then we said, what if we do not analyze the data as a time series data, rather try to convert these annual curves, the annual measurements, into an annual smooth curve, right? So we have here, for all the locations, we have 10 years of data. So if we take 1965, 1970, 75, so for each location, we have 10 annual curves times 16. So we have here 160 curves. And we see if we do the curves over an annual window, which is 12 months, there is substantial variability, right? And it immediately triggered a question to us to say, has there been any shift in climate, microclimates? Are some locations clustered together more in certain times of the year? And at a later stage, are the cluster belongingness changing? And for us, it was very intriguing to do functional data application. Is first, obviously, smoothing is a factor. The way you smooth can affect your analysis and conclusions. There's also something called registration or warping. Basically, in the investigation, are we going to treat the smooth data as is, or are we trying to align, say, the peaks and the valleys of the curve? And will that give us better understanding of the system? Okay. So basically, the functional data analysis framework tells us that you smooth the data into annual curves. The smooth is also a very simple way to put the exercise. There are many issues around smoothing. We investigate phase and amplitude, because now we have a curve. We can look at shifts on the x-axis, study them, or study the y-axis amplitude variation. What I did not put here is, because the curves are smooth, it allows us to investigate the rate of change in the curves. Are some peaks arriving faster than other peaks? So we can, through a smooth curve and through the functional data package, which is very well established, actually calculate the first derivative and the second derivative of the curves and actually study how fast the curves are accelerating. Are some peaks and valleys arriving faster or smoother, and does that give us an indication into how it affects the ecosystem in that region? Obviously, the curves allow us to use principal component kind of investigation or cluster kind of investigation. And as I said, the rate of change of the curves. So very briefly, if you have already done any work in functional data analysis, this is a redundant slide. But for those who may see it for the first time, basically X is your raw data. And we say at that point in time, TJ, we had observed X, but it is an observation from a potential continuum. So we say, Y is the continuum, and can we somehow say that we are converting X to an observation from a continuum Y? And there is a lot of literature in this space that you can read through to understand motivation and implementation of the smoothing techniques. What constraints you want to give on the smoothing technique. For instance, a day, you know, the peak is in the afternoon, and the trough or the valley is say around 4 or 5 in the morning. So we know there, what is the degree of the process. Okay, so in that paper, there is a lot of outputs, which if you are interested, you can see the paper. But just to give you a brief indication that we ran clustering of the curves. And if I just point you to, for instance, Pretoria, where I am, you will see Pretoria pairs closest with Klerksdorp, then with Johannesburg, then with Polokwane, and then with Dullstroom. If we go 5 years across, we see that Pretoria is still with Klerksdorp, still with Johannesburg, but its immediate next is Dullstroom. We are not close to Polokwane. Polokwane has shifted its allegiance to a different cluster, which is with Tabazimbi, which was far away 5 years ago. So for us, these are some kind of opportunity where we, with our statistical skills and the way we see data, can go back to, say, a geography person or somebody from the weather services and say, is this something that aligns with your knowledge of this region? And if yes, then have you any literature that says, and hence after this, these regions were actually seeing decline in a certain, say, tree population or indigenous vegetation or any other such response mechanism to change in weather. So you will see, this is also from the paper, Clustering Algorithm Revealed Evolving Cluster Membership Over the Years. And also this is from the paper, you don't need to read it, but basically whatever we found as statisticians, we wanted to summarize it in a way that may be useful for, say, somebody from geography to deliberate around, because they will not read your methodology section of the paper. And we cannot help beyond the methodology. So what are we doing next? So what I didn't tell you is the data that we used in that paper is actually model data. Okay, so it is data from a grid, evenly distributed grid, and we found the grid location from which was closest to the 16 cities of interest, and we got model data. It was not in situ data. So now the first thing for us was to see, can we, still keeping the framework of functional data, find in situ data from South Africa Weather Services, who are the custodian of our weather data, and interrogate further. We also know that historically in South Africa, there had been locations where temperature was manually measured. And over few decades, it became automatically measured. The question arose that what is the difference between manual and automatic measurements? Is there any? We know manual measurements, because they are not automatic, were only measured at certain points in time. Okay, some were measured only once during the day, which was at 8 a.m. Some were measured twice a day, which was 8 a.m. and 2 p.m. And then there were some that were measured at 8 to and 8 in the evening. Okay, is there a way to compare in situ data with model data? So then we would have to find locations where the model data was available and the in situ was available, then in situ, but manual and automatic. So there was a lot of questions that came to our mind, that must we be blind and take data as is given to us from weather services, or must we still interrogate that data before we even think of modeling? Okay. So for instance, this is a measurement, in situ measurement that we got from a certain location of interest. It had 2 stations. It seems both the sensors are always in the same box. So we know location is exactly the same. The red is the manual measurement, and the bright blue is the automatic measurements. And we do see we have the luxury of an overlapping period. So let's zoom into there. So this was measurements from 1980 to 2020. Around 92, we saw that the conversion from manual to automatic happened. So when we zoom into that year, which is 1992, it was quite interesting. We saw the manual measurements were being made. Then there was a time when the automatic station was starting to measure, and then there was automatic station was not measuring. There was a big gap. And then there was overlap again. And we do see there is minor variations. Now, are these variations human error variations? In that case, what kind of adjustment, if any, must we give to that region, which is pre-automatic instrument period? And then go forth with our standard procedure of functional data analysis. So what I'm trying to emphasize is, even before you have access to a fantastic tool, interrogate the raw data as much as you can. Go back and forth to the climate specialist and ask any questions that bothers you before you say, okay, now I have the data that I'm going to call within the program. Okay. The good thing about functional data, as we said, it allows us to handle mixed frequency, which is great because manual data didn't do hourly measurements, whereas automatic did hourly measurements. The smoothing then allows us to model a continuum. It will allow us to compare manual automatic measurements, will allow us to explore, say, if I want to see how was the temperature being affected by humidity or rainfall or wind under the functional regression framework. We can investigate if there were any regimes of change. So was there a point beyond which a significant change happened, but again, in the functional framework? And the aim is later to extend it beyond a single station with in situ data to see whether how we can map the whole region and still investigate spatiotemporal variations. Okay. So who are my partners in this current research? Obviously the South African Weather Service, who are the custodian of the data and with whom we have signed a non-disclosure to work with. The Musk Center for Applied Mathematics, this opportunity came under award I received from Spain earlier this year, which gave me a fellowship to work with a partner institution in Spain. And BCAM is one of the institutions that does heavy work on spatiotemporal modeling under the Bayesian framework using functional approach. And also Department of Statistics at the University of Illinois, who also are proficient in functional data methods. They have a lot of contributed R packages, so they are really experts in the field. Okay, this is my last slide. So if I've gone overboard, I will finish as quickly as I can. So basically, this is more for our younger audience, students who are starting off in the field, that each of us learn tools within the curriculum that we specialize in. But when you're doing practical research, always be vigilant about who you are. Do you know who you are, where you belong? And this is not demographics. It is me in the context of my ecosystem. Do I understand what the problems are in my ecosystem? Am I able to articulate and formulate them into a problem where I can use my tools to provide solutions, right? So basically how to convey our problems to the world and how to convey our solutions to the world. So basically taking ownership of our problems. And there are a lot of problems. And because we are in the Women's Day week, just to remind that each of these words that I've highlighted are words that identify with usually exclusion rather than inclusion, but well, I am a female statistician from Africa. So thank you very much and stay safe.
Many thanks to you, Professor Das. Now the discussion is open for attendees and panelists on the same time. If we have any question to Professor Das.
Excuse me, please leave questions at the end. Okay?
Okay. So at the end of
Okay.
the
questions
session
and discussions at the end. Okay.
Okay.
Okay then. Well,
Okay, so yeah, then we can start with the next speaker, right?
Yes.
Dr. Saleh? Okay, let me introduce the next speaker. So is Dr. Hazali ready?
Yes, I'm ready.
Okay, we can't see you.
Okay, so
So our next speaker is Dr. Hazali, and it gives me great pleasure to introduce him. He is from Tunisia, so from south of the continent, you are now taken to the north of the continent. And he works on geology. And as I said at the beginning, it gives me great pleasure to see that each of the talks are very, shall I say, cross-disciplinary or interdisciplinary. So with his skills, he is trying to do something that affects a variety of researchers and people who benefit or not benefit from it. Dr. Hazali, the floor is yours.
okay, so thank you very much, and good morning, everybody. So now I will, okay, just I need to share the video for my participation.
Yes.
Okay, so to avoid internet issue, I prepared the video for my participation, and so do you hear the voice? Is it okay now?
Dr. Hazali, are you not presenting it live? Is it a recorded talk?
Yeah, it's recorded to avoid an internet issue.
Okay,
Okay,
that is fine. But if you can put the audio a little higher,
okay.
maybe put the audio close to the camera. And if you can, maybe then close your camera so that I think the bandwidth will also help them.
Okay.
Dear Professor, dear colleague, it's a great pleasure for me to participate in this international conference and share knowledge and challenge with you. In this study, I used seismic advanced tools like seismic attributes and spectral decomposition in the objective to define ocean reservoir structures like reefs and bright spots. In Tunisia, ocean carbonates show challenge to engineers and geologists to characterize it because of their tendency to be tight and internal heterogeneous due to the depositional and diagenetic processes in all directions. Although seismic data exists over the prospect, it's hard to map the reef buildup characterized by a range of seismic reflection attributes patterns by using conventional seismic interpretation tools. The limestone of the ocean reservoir constitute a very known type of depositional system and contain significant volumes of hydrocarbon in onshore and offshore central Tunisia. The sea level fluctuations and regional tectonics influence the distribution of carbonate platforms, in particular reef systems. These buildups may be considered as potential reservoir and can represent an additional target for hydrocarbon explorations. In this study, seismic instantaneous amplitude and frequency have been used to identify reefs and bright spots. Seismic phases and geometries interpreted from the attribute analysis and seismic inversion are combined with the original data. Also, seismic attributes extracted from the seismic data were pivotal when investigating their own reef and off-reef properties on ocean play along the sonar. The seismic attribute is defined as any measurement derived from the seismic data. Seismic attribute typically provide information about bright spots, thin effects, and discontinuities. Otherwise may not be noticed relating to the amplitude, shape, and position of the seismic waveform. In this section, I will show an illustration of reef identification by using seismic attribute. In central Tunisia, due to hallucinosis, seismic is not available to make a strong contribution in understanding the large-scale phases distribution. As well, the seismic signal is poor and horizontal interpretation can be difficult. The attribute analysis of this seismic line show that the surge reef complex displayed an asymmetrical overall architecture with discontinuous seismic signature within the reef interior. However, the internal facies of the reef were determined to be under the detection limit of the seismic data. The seismic profile is pointing out to the series of small and isolated seismic scale reef limestone with tabular and polygonal geometries, so-called patch reef and pinnacles. These build-ups are characterized by their highly amplitude anomalies and Monday reflections. The major outcomes are as follows. Reefs are identified by their specific shape and particular internal seismic phases. Also, the seismic characteristic of reefs identified change from low to high amplitude, low to good continuity reflections, and chaotic or even mounted internal reflection patterns, and exhibit apparent amplitude anomaly on seismic profiles. As well, some small and isolated patch and pinnacle reefs are recognized by their strong amplitude anomalies. In particular, reefs are often affected by dolomitization, which increases porosity in conjunction with fracture networks. In this section, I will show an illustration of bright spot and discontinuities by using spectral decomposition. The spectral decomposition is widely used for imaging and mapping seismic features as a function of spatial position, travel time, frequency, amplitude, and help us to visualize, interpret, and quantify the seismic response to an extent that was previously unattainable. The original spatial distribution and lateral extent of amplitude anomaly may vary after phase decomposition, allowing the interpreter to better assess and prioritize target. In this work, the definition of the necessary frequency content for the seismic data can be obtained by building synthetic frequency covers from well data and applying phase decomposition on this. In particular, the thin layer requirement, the bright spot, can be achieved by high cut filtering the data, increase the thickness, or running the attribute in selected frequency depend amplitudes from spectral decomposition. The main results show that the final plot confirms that the 70 Hz components are dominant in the seismic data and that the bright spot structure and discontinuity are evident in this frequency. The results of spectral decomposition are usually displayed by RGB blending. The 70 Hz response of the bright spot appears in red and contrasts with the enclosed sediment that appears as dark gray color created by the mixture of all the other three colors. Compared to standard displays, RGB blending creates informative multi-attribute displays that show feature in finer details. The main conclusions are as follows. Seismic attributes and spectral decomposition are effective in extracting subtle features which are sometimes hardly identified on original seismic data. Moreover, in practical application to obtain more reliable reservoir information, these studies are far from enough. It's necessary to carry out more in-depth studies on strata information by integrating other data. More interpretation methods such as detailed AVIO analysis can be combined to derive final probability of success to support drilling decisions. Thank you for your attention. Dear Professor.
Thank you, Dr. Harzali.
Thank you.
So,
Okay, thank you very much.
thank you very much. I think as Professor Amin said, that we will save all our questions to the end. So
Okay,
we'll
inshallah.
see hopefully again.
Okay.
And if Prof. Al-Qatani is ready, we will then move on to the next talk.
Yes, hello, I'm ready. Yeah.
Just Sukina, one thing. Dr. Harzali, if you can stop sharing your
Okay.
screen.
Okay, I stop it here.
Yeah. We can still see your screen.
So,
So I think somewhere at the top you will see stop sharing.
I will leave the meeting and I will come back.
Okay.
That's
Yeah,
right.
no, that's
Okay.
fine. Yeah. Yeah. So, Sukina, if you're ready, we are ready.
Sure.
So,
Morning.
so let me briefly introduce Sukina. So it gives me, I'm calling her by her first name because it gives me great pleasure
Yes.
that I know this wonderful researcher, wonderful scientist, very passionate scientist, and it is not just the technical aspects which she can influence an audience. It is also, the commitment to her field, which is very important and something younger students should hear and learn from. And the kind of work she does is really top of the range. So I'm very proud that today in the session, I am able to introduce Sukina. So Sukina, the floor is yours.
Thank you. Thank you so much. It's always a pleasure actually to be part of the Women in Science Without Border Forum. This is my fourth time actually to attend this pioneer initiative, okay? And I'm glad actually to have it this time. I was hoping that we can go to the hook, okay? And meet all of us, but hopefully at some point after this COVID done, okay, we will meet up, inshallah. Actually, what I'm gonna show you today or share with you today is one of my running a project right now in Jordan, which is about social distancing application because of the current situation around the world, okay, and how most governments are going to look down from time to time. So my project title is Employing of Facial Recognition System in Public Surveillance Cameras to Enforce Quarantine and Social Distancing using Parallel Machine Learning Technique. Actually, an outstanding team, okay, who helping me to run this project, you know, in the right way. First of all, I'm gonna just give you a brief about why we're doing this, or why the idea of this project is going out. But by the way, the idea of the project is not a novel one, okay, because now most of countries, okay, trying to find a way to enforce quarantine instructions, okay, especially with people who cannot actually, you know, who are used, okay, to have their free life, okay, to come and go freely, okay, without any restrictions. So the idea actually it came from what's going around us in the world, okay. So we thought we will take the idea, okay, but find a different application for it, using a different tool to make our system one of the best in the region. You know, actually, in the middle of 2020, Jordan decided to go in a general lockdown. General lockdown was for 3 continuous months. So people then were not allowed to leave their houses. They're not allowed actually to go in the street, to go work or whatever. We suddenly turned to work from houses. And the government had to ask the army to go in the street in order to enforce the law of that, because it was hard for people to understand why we are going through the lockdown. You know, seeing the army in the street was a bit annoying for we understand they were there, okay, to protect us. But, you know, when you see all this stuff, okay, all these cars and army attendants outside, you don't feel comfortable. So we thought with that, why we don't reduce the amount of police officers, army in the street, okay, and utilize something already exists in most places, which is the surveillance cameras. These stuff exist actually. You know, these type of cameras exist everywhere. Almost many, or not many actually, almost most companies, even resident, okay, people resident and so on, they have surveillance camera around. Something is one of the main measures, okay, that all has to take, you know, to bear in mind, okay, in order to reduce the widespread of the COVID-19. So what we thought about, let's try to find something to really, introduce a system that can use this camera in order to alert the authorities where people break the, you know, the law, where people, okay, you know, get out when they're not allowed to go out. Thinking, I know it might sound a bit, you know, uncomfortable for people to be controlled, okay, through cameras and thingy, but this is actually what we need in order to stop the spreading of the virus. So in our project, we thought what we needed from this camera is to detect the crowds and measure the social distancing between them. We use a motion detector, and also we provide the facial recognition system that sometimes if the people are standing in a frontal view, okay, we can actually capture and these people, okay, and identify them. So it will be easy to know who's that and to get the authority able to, you know, to apply the law. This system actually works in real-time base. What our system exactly do? It will detect, track, and measure the social distance of any moving and the static bodies. And, you know, in order to be more specific, what we do, we identify the social distance, you know, the distance that we need in order to consider people having social distance or not for 6 feet, which is 2 meters. And, we actually identified as well, okay, the bodies we want. For example, we don't want, the pet or any cars or whatever. We just concern about human bodies. So we identify the human body average. So our system can track just moving or standing people. If the people face were frontal, okay, the camera will scan it and send all the collected information to the authorities. Our contribution actually was, we had, applying the social distance system. We don't consider it as a major contribution. What we consider it is the technique that we use, the algorithm we use in order to make our system fast, able to deal with large amount of data in a professional way, using something called parallel computing technique. And we combine between parallel computing and machine learning technique, okay, in order to make the processing of this data very sufficient and accurate. Here, just I'm going to show you the design of our system. We actually try to detect any moving object. Then this object, we will take it and try to, if the picture was frontal, okay, we will be able actually to detect scan the face and try to identify it. If not, we just actually take the object itself and alert the people who's actually using the system that there is a crowd or there is no social distancing in different places. When we try to apply, actually we're still running this project, we start facing some issues with facial recognition system, which is people are asked to wear a mask. So when you are wearing a mask, we will be unable actually to identify the person because, for facial recognition, you need to measure some features, okay, actually to extract feature from the human face in order to be able to identify who is this person. So we had to find a backup plan to deal with this situation. We added a bit of mask detection as well. So we thought, okay, if we are unable to detect who is this person, okay, at least we know from where he came. And we can actually add to this if he's wearing a mask or not. The idea of all these precautions, okay, is to make sure people keep social distance, they're wearing mask, okay, in order to reduce the spread of this virus. So at the end of the day, we don't want actually to catch people. What we want people to be aware of these precautions. So if they're wearing masks, if they're keeping their social distances, nothing, okay, we will do against them, okay? But if they're not, we have to warn them and we have to tell, the authorities in different places, okay, about that so they can warn them. Now in Jordan, what we do, or actually not me, okay, but what our authorities do, if, for example, if they meet you and you not wearing a mask, they will fine you about 60 JD, which is around $100, just a mask. Also, and you can imagine the amount of people working in this, okay, just to catch people who is not wearing a mask. For social distancing, okay, they will find the place, the workplace or whatever, okay, if there is no social distance between people, okay, and they reduce actually the amount of sitting, they reduce the amount of places where the crowds can get there. Actually, there is no, they don't allow, okay, to have any crowd gathering in different places. Here, what I'm showing you, okay, we just tested our system, okay, in the for the basic operation, that when people are working together, okay, it will show the violations, okay, for the social distancing. And you can see, for example, when it's the green that there is a good distance, when there is red, okay, that means the people are close to each other. It's the authority responsibility actually to deal with the situation. The technical contribution of this work, as I said, such system is used in different countries, in different places. But what we try to do is to use a good facial feature extraction system, okay, for discrimination, and to use a very fast and reasonable system that can deal with all or overcome many problems such as the cost, the speed, and time consuming, okay, for high performance processing. What we, in order, actually, we already designed the system, but now we need to apply it. It's not easy actually to go to the authorities and say that, okay, look, we prepared this system, we want you to adopt it. We tried actually to make a pilot, to test our system through a pilot project in my university, here at Zaytuna University of Jordan. We already have a risk management plan. And this one, okay, this plan was about, how we gonna apply the precautions process in this way. What we did, we actually, in my university, we have around 200 surveillance cameras, and these cameras are connected with the internal guards, okay, who are their duty is to make sure that students and staff, they don't actually break any of our regulations. So we apply it in different where we expect many students will be there, or many staff will be there, for example, in the registration hall, in different in financial hall, okay, because now we are working we do the online teaching, so we don't have that much of the student here, but for the registration many students come, so we take advantage of having many people coming, okay, and try to test our system. What we do, the camera will collect the data about the people there, where we can find no application of social distancing. An alarm will go to the guard for each building and tell them, show them who's there, and if it's possible for the camera, to show the faces for the people. In the same time, okay, it will show them for normal people, okay, who's who keeping the social distance, but they're not wearing the mask. It will show them that, there's people, they're not wearing the mask. So they can warn them, they can ask them to wear the thank you. This, we are hoping, now we are actually in a procedure to collect our results, okay. We're hoping that it will, this thing here, okay, it will show if the social distance actually measure, is it the right thing actually to do? Is this way the right way actually to make sure we keeping our institution actually safe or whatever? We actually trying to figure out if this is the right way to do the thing or not. Actually, my project is supported by the Deanship of Scientific Research in Zaytuna University, and I got an award for it. And that's it. Okay, this is about my presentation today. Thank you.
Thank you very much, Sakina. It's always exciting to hear your talk. And as we have agreed, we will save all the questions for the last, because I have some question for you.
Okay.
And if our next speaker is ready, then if you can stop sharing your screen, we will invite the next speaker.
Yeah, sure. Sorry, stop sharing.
Professor Al-Mukhtar?
Yes, doctor, I am ready.
Yes, but we can't see you.
Yes, one moment, please.
Perfect.
Morning, everyone.
Morning, Professor.
Morning.
Again, great pleasure to introduce Professor Al-Mukhtar. His biographical details are there in the book, in the PDF document, but very briefly, he works in a very important space of water resource management, which includes both, water and wastewater. And we know that water is also divided into potable and non-potable, and the whole space of how it is getting affected with regards quality and quantity from many different triggers is a concern for everybody. But his, I think, contribution is more from the angle of modeler, models, data, all that kind of speciality in the space of water resource management. So Professor Mukhtar, I welcome you to present your talk.
Yes, 1 minute, please. Is it okay now?
Yes, I can see it.
Let me get the slide here. Good morning, everyone. It gives me a great pleasure for being here today in this World Forum for Women in Science. Firstly, I would like to thank the organizers for inviting me as a speaker for this event and give this presentation, actually, which is a part of my latest research in the field of water resources engineering, entitled Modeling the Monthly Ban Evaporation Rates Using Artificial Intelligence Methods, a case study in Iraq. This presentation is, as I mentioned earlier, it is a part of a published paper in Environmental Earth Sciences published by Springer. And let me give a brief introduction on the outlines of this presentation. The presentation contains firstly an introduction about the topic. Thereafter, the study area will be explained, and then the methodology, and followed by the results and conclusions. As you may know, the water is the most precious resource for the existence and survival on the Earth. 3/4 of the Earth's surface is covered with water. Out of this, 90% is salt water, unfit for consumption, and only 2% of the total water is fresh and can be consumed. This necessitates the importance of proper water management, and this is especially and critically important in arid and semi-arid area like in Iraq. One of the most critical issues we are encountering in the field of water resources is the evaporation. What is the evaporation? As you can see here, the evaporation is when the energy exerted on the water surfaces is used to break the bonds that hold water molecules together, and then the liquid changes to the gaseous state. Upon this, the water molecules escape from the surfaces. Why the evaporation is an important issue in water management? During the last century, due to the human activities, especially burning fossil fuels, which release carbon dioxide, methane, and other greenhouse gases, there has been a gradual heating of Earth's surface ocean, which in turn lead to what is called climate changes. These climate changes has imposed an increase in the heat in around many parts of the world, which in other words cause a more evaporative losses. These evaporative losses ultimately lead or cause or results in a decline in water levels in dams and reservoirs. Also, the relationship between the evaporation and the water management. The evaporation might impact the quantity and the quality of both surface and groundwater. This can increase the salinization of water and soil. and subsequently the water quality deteriorate. And this in turn might lead to loss many hectares of agricultural areas. Let me move to the study area, which I considered in my research. The study area encompasses three different meteorological stations distributed across the Iraqi territories. The first one was the Baghdad station, which located over the latitude and longitude here mentioned here, and the altitude of the station was 41 meters above mean sea level. And the second meteorological station considered in my modeling was the Basra in the south of Iraq, which located here, latitude, longitude, and the altitude 6 meters above mean sea level. And lastly, Mosul station was also considered, which is located in the north and with 28 meters above mean sea level. This was to confirm or to make sure that our modeling will undergo a robust evaluation when considering different meteorological area with different characteristics. The data collected for the modeling was as following: the maximum monthly temperature, minimum monthly temperature, relative humidity, wind speed, and the band evaporation. The data spans over the period 1990 to 2013. The data was firstly statistically analyzed. For example, you can see here, these are the parameters considered. Should I mention the band evaporation, which is the what is we call in statistics, it is the predictant. These maximum, minimum, relative wind speed, we call it the predictors, and this the band evaporation is the predictant. So something like the dependent variable and independent variable in the statistics. The band evaporation, for example, in Baghdad has a minimum value of 48 millim, while the maximum value was 624. The mean value 264, and the standard deviation 161, and the coefficient of variation 0.61, and the skewness was 0.32. As I mentioned, these data was analyzed in order to give a better insight about the behavior of the data. The applied artificial intelligence methods used in this study was the random forest method, the quantile regression forest, the artificial neural networks, support vector machines, and multiple linear regressions. In total, 5 different algorithms used in order to model the band evaporations across the 3 stations in Iraq. Also, I examined several structures to model the evaporation. I mean, in the first structure, I used the relative humidity, the minimum, maximum temperatures, and wind speeds as independent parameters. While in the second structure, I used only the relative humidity, minimum, and maximum temperatures. Lastly, the third structure was considered only the minimum temperatures and maximum temperature. This also
Dr. Al-Mukhtar, your audio is
comprehensive evaluation on the robustness of the model.
Dr. Al-Mukhtar, we can't hear you. I'm not sure whether we have lost connectivity with Professor or not.
I think he might have the power went out or something like that.
Yes, yes. I think let us go to the next speaker, and when he is back, we give him his allot. Oh, there he is back.
Yes.
Wonderful. Sorry, Professor. Your the last slide onwards, we lost connection. So if you can start from your last slide again.
Which one?
Can you kindly turn off the camera as well?
If you can share the slides, we can tell you.
This one, please. Yes, I am sharing now. Moment.
Yeah, your voice was fading and then we lost connection.
Mm-hmm.
So we can't see your slides yet.
Now it is okay.
Yes. So this slide, we could, at least I could hear nothing. So if you can start from this slide again, please.
And
yes.
Dr.
Yes.
Dr.
Okay. Thank
Mustafa.
you. I'm sorry about that.
Dr. Mustafa, can you please turn off your camera so that we
Yes.
can save the bandwidth for the internet?
Yes.
Just to maintain the internet speed. Thank you very much.
Is everything okay, Professor?
I am trying. Yes. Now I turn off my and now I will share it
You can
again.
start.
The slides is appeared here, or it's okay?
Yes, appear.
Dr. Omar, is
Yes,
it okay
please.
now?
Go on, please.
Yes, everything is perfect. You can start.
Yes, I was talking about the structures to build the models. The first structures considered using the relative humidity, minimum and maximum temperatures and wind speed, while the second structure was or considered only the relative humidity, minimum and maximum temperatures, and lastly, the third structure used the minimum and maximum temperature. As I said, this was to ensure that the models will undergo the comprehensive evaluation over these three different structures. The models were evaluated using several statistical metrics, that is the relative, the determination coefficients, the root mean square error, and the Nash and Stochastic coefficient efficiency. Also, the Taylor diagram, which is a 2D graph plot used to identify the relationship between the observed and the modeled data, was used to give a better insight about the model performance. The results was analyzed or were analyzed as shown here. For example, in Baghdad, the scatter plot between the observed ban evaporation and the modeled ban evaporation for the 5 methods were plotted here. For example, this one represents the performance of the quantile regression forest. You can see that the scatter dots distributed evenly around the line 1-to-1 or line 45 degree. In the same manner, the random forest performs also in a good or a well performance. The artificial neural network and the support vector machine, and also the multiple linear regressions. All the 5 evaluated methods performed pretty well, but however, the quantile regression forest was the optimal or the superior one. You can see here the Taylor diagram. This dot, colored dot, represent the various or the applied method. The red one represents the quantile regression forest. This red dot one is the closest one to the x-axis, which represent the observations from the field. And this, in other words, means that the quantile regression forest was the optimal one. Also in Basra, the evaluation was not big different on that from in Baghdad. The quantile regression forest was almost the superior when compared with the other evaluated methods. And lastly, in Mosul station, the evaluation was also revealed. The evaluation revealed that the quantile regression forest is the optimal one to model the band evaporation. Conclusions: the maximum evaporation rates were recorded in Basra, south of Iraq, while the lowest one were in Mosul. The quantile regression forest outperforms the other evaluated methods across the 3 studied stations. Also, the quantile regression forest can be efficiently used to model the evaporation rates. And lastly, the optimal input parameters to model the band evaporation in Iraq were the maximum monthly temperature, minimum monthly temperature, relative humidity, and wind speed. Thank you very much. I apologize for this losing connection.
Thank you, Professor Al-Mukhtar. No, I think you were still well within time, so we are fine. And if our next speaker is ready, Dr. Pati, then I will request Prof. Al-Mukhtar to stop sharing the slides.
Yes.
Then Dr. Pati can upload slides. Yeah. Good morning, Dr. Pati, and it gives me great pleasure to introduce you because you are a fellow statistician.
Please let me share my screen.
I'm saying it gives me great pleasure to introduce another fellow statistician.
It's okay?
Yes, we can see it perfectly. So you can start your presentation.
Okay. Assalamu alaikum. For all organizer and participants, I would like to present my research under the title Using Robust Rich Regression Diagnostic Method to handle multicollinearity cues high leverage points. Methodology: rich regression estimator, robust regression estimators, list stream square, results, and conclusion. Introduction. Ordinary list squares, OLS, is one of the oldest statistical method to estimate the parameters because of its optimal properties and simplicity to computation. However, affected by the existence of multicollinearity, we proposed some alternative methods to estimate the parameters in presence of multiple high leverage points, which cause the multicollinearity problem. We incorporate the robust list stream square LTS estimator to downweight the effects of multiple linear high leverage points, which leads to reduction the effects of multicollinearity. Methodology. There are two problems affect a set called multicollinearity fused high leverage point and outliers. However, in this paper, we proposed two methods to handle these problems called rich regression that dampen the multicollinearity and robust less string squares LTS estimator used to reduce the effect of outliers, and we used it because it is more efficiency and has 50% of high leverage point. This is multicollinearity. The first problem that the presence of it produces poor estimate parameters in the regression coefficient, knowing that OLS estimate is unbiased. Also, it is a problem where two or more explanatory variables are correlated with each other, or they are highly linearly related and give an inaccurate prediction about the dependent variable. The regression method is the procedure to reduce multicollinearity. Outliers. Outliers is the other problem affected to estimate the parameters. However, outliers can be categorized into two types. The observations with large residuals are also known as vertical outliers. The second type is high leverage points, also known as horizontal outliers. Robust regression is an alternative procedure to ordinary least squares that dampen the influence of
I think we have lost Dr. Pati's connectivity.
Exactly, that's what I think.
Let's give her a bit of time because she is the last speaker and we still have some time.
Okay.
By modifying the method of
back.
least squares to allow biased estimators of the regression coefficients. The rich regression estimator is defined as follows: beta hat equal to X transpose X plus Ki all inverse X transpose Y, where K is unknown constant adding to the diagonal of the correlation matrix X transpose X, and I is the P by P identity matrix, where also K equal to rho S square OLS over beta hat transpose OLS multiplied by beta hat OLS, and S square OLS equal to Y minus X beta hat OLS transpose multiplied by Y minus X beta hat OLS all over N minus P. Also, this formula equal to, this is error transpose multiplied by error over N minus P, where N is the sample size and P is the number of the parameters. Beta hat rich is biased, but more suitable and precise than the OLS estimator. Robust regression estimators have been confirmed to be more reliable and efficient than the least squares estimator, especially when disturbances are non-normal distribution. What does that mean, non-normal distribution? Non-normal distribution, disturbance distribution has heavy or fatter tails than the normal distribution and tends to produce outliers. Robust procedure fit a regression dampen the impact of the influential points. To reduce outlier, we look for those points that lying far away from the pattern formed and have large residual from the line regression. Least trim squares, LTS. The LTS estimates are obtained by finding the regression model parameters to achieve minimize summation yi minus beta naught minus beta I xi all square. In other words, minimizing summation residual ei squared where e1 square less than or equal to e2 square less than n, and are the ordered square residuals, and the value of h must be defined by h equal to n over 2 plus p plus 1 over 2 to obtain the number of observations in each subsample. After the summation, the square residuals for each subsample to obtain the single value, select the minimum residual for each subsample and use the parameter of these residuals for the original observation. Results. From table 1, we observe that estimate of parameters in performance of the proposed rich estimator is better than OLS for all combined predictors and give the summary results of statistics. Also, the results from table 1 relieve the influence of outliers of the regression model when OLS is used to estimate the regression parameters and compared with the another regression parameters obtained from the LTS estimate. On the other hand, when considering estimated the result obtained from the body fat data, the involved 3 explanatory variables. These tables provide the breakdown point result of the estimated parameters using OLS and rich regression, LTS, and rich LTS regression. The criteria used to evaluate the best regression model is using the standard error and t-value estimated from the body fat data involving all the explanatory variables based on the results obtained in table 1 and table 2. The RLTS possess the least standard errors with largest t-value compared to the t-value obtained from LTS and OLS. This is table 1, summary of statistics for the body fat example. Here we use the real data, body fat data. We have here methods. We used this method to to get the results for the data. We have OLS original and OLS transformed, and the method rich, and the another method LTS and RLTS. And we have these parameters estimated. We have this beta naught, intercept, and we have beta 1 and beta 2 and beta 3, because we have 3 explanatory variables and use multiple linear regression. And in table 2 also, we have summary statistics of the standard error and t-value for the body fat example. Also the same method, but we use another criteria, use here standard error and t-value to estimate the parameters in the multiple linear regression. Conclusions. The performance of the proposed method is better than other estimators used. The principal focus in this paper would be to produce reliable techniques to solve the problem of the multicollinearity in the presence of the outliers. Even though empirical study discloses the OLS estimate is often impacted by the outliers, conclude that OLS isn't reliable also in presence of multicollinearity. However, the RLTS arises to become basic all data efficiency and much reliable because it is less impacted by the outliers. Finally, the outcomes appear the point out of the LTS and RLTS method provides a substantial improvement with the other existing technique for solve the problems of multicollinearity in the data. Thank you very much. I am ready to answer any question.
Yes, thank you. Thank you, Dr. Pati. I think the question answer session will be handled by the co-moderator. So if you can stop sharing your slides, then we can let him take over the session.
Yes, thank you very much for all the panelists and specifically Professor Das for the efforts you have put on your presentations. And now it's question now is open for everyone. I have no written questions.
Yeah, I just want Dr. Pati, if you can stop sharing your slide, please.
Okay.
Yeah, I think it would be nice if all the panelists put their camera on now, including myself.
And I will open my camera as well because I want to take photo with friends.
Yes.
Yeah, nice to see you, you and Sukaina after that long time.
Yes.
Even online, it's better than nothing.
Sukaina. And Dr. Pati, if you can put your camera on, please.
Yeah, Dr. Kafi.
Where is Sukaina?
No, she's here. She's here.
Yeah, open your camera. How are you?
Fine.
Nice to see you.
Thank you very much.
By the way, I'm not concerned in your session, but I really enjoyed the session. It's multidisciplinary.
Yes.
It was a very nice session.
Pleasure. It's a pleasure to meet you, Professor Amal.
Me as well.
So much from Dr. Suhad and Dr. Abtisam about you.
Yeah, Dr. Omar, you are the colleague of Dr. Shaheen?
More or less. We are colleagues. We are all in the University of the Hope. I'm an engineer. Yeah, I'm an engineer. Yeah. I'm working in the electrical department. I'm actually a son of Dr. Abtisam.
She talked about you, yes.
Yeah.
Yes.
Sorry,
nice to meet you. Nice to meet you.
If you can do a print screen, I think it will be easier to get a picture. Just do print screen with your keyboard.
Yes, sure.
Dr. Shaheen, please take photo.
I think
Shaheen?
the person has just left.
Shaheen?
The other session.
Okay.
Question is-
If the floor is open for questions and if the moderator
Shaheen?
allows, I have
No,
a question.
Shaheen is here.
No, Shaheen is not there. She said that he will be at the other session because they will start soon, and she has to prepare stuff. I'll take the photos and I'll save them.
Yes, please take photos.
Yes, sure thing.
Dr. Salih, I have a question.
I took one shot.
Dr. Omar, have you taken the photos?
I am taking photos.
Oh, okay, thanks. Thanks a lot.
Can I ask a question?
Yes, sure. Go ahead.
Yes. My question is for Sukina. This research obviously is two-pronged. One is to help administrators manage, that people are not standing too close or not wearing masks. But on the other side, you said facial recognition will help you identify the person who is not meeting, say, the guidelines, the social distancing guidelines. How do you manage ethical issues like privacy and surveillance in this case?
Well, thank you for your question. Actually, we are, as a researcher, okay, actually, when we tested our system, we used an available database, which is the Facial Recognition Grand Challenge database, okay? And this database is really, available for use, so no ethical issue with using picture. Now, when we handle the system, for the internal ministry in Jordan, okay, actually they are, okay, the official authorities that are handling most the surveillance camera in Jordan, okay, in public area. So it's their actually responsibility to deal with the ethical side of that, because they using it now to enforce the law, okay, either for traffic or whatever. So they are the only authorities are allowed, okay, to use it. Let me tell you about in our university. In our university, actually, we had this concerns before, but then the university, they asked, they bought a kind of announcement near all surveillance cameras telling that this building is controlled by surveillance camera. Your picture will be used, okay, to control, the for the safety and security purposes. So we announced that. But to be honest, I think with this, with telling people this, okay, they know that we will use their pictures, okay. But how ethical is it? I'm really not sure, okay, if people will get offenses about using their thingy. The idea of this system is to reduce the number of people actually who's, what we had, why this idea came. What we had, there was, Jordan had to put all its army, okay, in the street. In each street you will find a car and about 4, 5, 6 army people, okay, there. We thought that seeing such a thing, okay, in our street is making us feel unsafe, unsecure, and whatever. Even they are there for our safety. So we thought, okay, let's get rid of this situation, and the cameras everywhere, okay, so use it. I don't know if I answered.
I think it depends on how it is to be used. If you are trying to find a specific individual and giving a protocol, then if we say, okay, 95% of the people are wearing masks because we are not able to facially recognize, then compliance. Yeah. If it is less than a number, then we say, okay, that specific region has compliance issues. And I'm not necessarily interested in finding Sonali, but I'm interested in putting a bit more vigilance in that area.
Yeah, yes, yeah. Yeah, we care more about actually, actually this system, it can be used for other purposes, But in our project, we just connected with the precautions thingy. But the authority, they might use it, okay, for other purposes.
Yeah.
Yeah.
No, I think that was my only interest because privacy issues are coming out very much in all countries, right?
Okay, may I ask a question,
everywhere.
Dr.
Yeah.
Sukaina?
Yeah, sure, go on.
In your project, you are taking actually the distances between every two adjacent persons.
Yes.
And it has to be maintained to 1.5.
Yes.
You know, there are specific cases that when you have like, there are a couple who lives in the same house.
Yeah.
Or there is the mother and son, and there is the people on the wheelchair who needs assistance.
Yeah.
Have you put these into considerations? Like you have to have a specific ideas about who and how to recognize that from the people who are violating the COVID-19 measures?
Yes, thank you for your question. You know, who gonna take this action? The one who, you know, the guard person, you know, the system will not go and, it will show that there's people violating, okay, the instructions, okay. But the person who's in the control, okay, who's looking at these people, okay, and get alert, he can tell that, you know, this, for example, disabled person need assistance. This kid needs, okay, you know, to hand his mother hand. But at the same time, you know, he has to check another factor, which is the wearing the mask and whatever, you know.
Okay.
So we actually test the social distance and the facial mask, okay, at the same time. Now, who, you know, the person has the authority, okay, who he can decide according to the situation if this violating the system or not.
Understood.
Okay.
Understood.
Yeah.
Professor Mustafa, I have another question actually about your work.
Yes.
I'm so far away from the concept, but when you are talking about evaporation, are you specifying a specific area of that evaporation? I mean, how did the measurement or the measurement can be done? Had the measurement been done or can be done?
Yes. Firstly, I apologize for the poor connection.
No,
It was out of my control.
Okay.
The evaporations we typically measured in specific meteorological stations. For example, there is a specific stations where we put a ban, like ban, and then we put inside it water, and then leave it for a specific time, and then we measure how much water decreased in this pan, and by this we can calculate the amount of evaporation in this area. This is the typical way to measure the pan evaporation in situ.
Okay, so was that a specific point in Baghdad, or you have multiple points in Baghdad, in Basra, and in Mosul?
Actually, we have several stations around the Iraq territories, and one of them in Baghdad, Basra, Mosul.
Yeah, no, I meant
station.
Yeah, I meant in the specific location, like you said, in Baghdad, for the case study or for the specifically. Do you have just one station, or do you have a number of stations that are distributed in Baghdad, so that you have more realistic?
Yes,
case?
I know probably it is only one station. By the way, this station measured not only the pan evaporation, but also the rainfall, the temperature, wind speed. It is as I mentioned, it is a meteorological station. It means that it measures several climatological and meteorological parameters.
Yeah. Okay. Okay. Thank you for your answer.
Thank you.
Professor Das, can I have one last question? It's about your work. I was concerned about the application that you might use it for. Like, from what I understood from your from a paper, you were trying to analyze the change in the temperature that you had throughout South Africa.
Yeah.
What sort of application that you can use it in? I mean, will there be a follow-up for the applications, or?
So the story, I think the initiation of this was that in working close to ecologists, there is a northeastern South Africa called the baobab. It lives for very, very long years, and its conditions to flourish are of a specific kind. But over the last few decades, researchers have found that that region, these trees, no new trees are coming, and the old trees are dying. So it is almost as in response to some climate change, right?
Okay.
So we want to understand that is it only that which is very obvious, but also maybe agricultural crops which may be responding differently, which affects farmers' income and livelihoods and land use practices. So what we then decided is to see whether through these methodology was there a better way to find shifts in climate patterns in specific regions. Are some of them becoming less humid over the years and not returning back to initial humidity conditions, or what? It is more complicated because we are just studying temperature now, but temperature doesn't do things by itself. Temperature in conjunction with humidity, rainfall, there are many aspects. So together in this multivariate scenario, can we say there are some regime shifts spatially and temporally? Right?
Okay.
And I think our wisdom stops there, because then we take the results to say that the ecologists or the environmental people or the forestry people and say, we have found this, that yes, indeed, these regions are becoming less, the conditions in the region are becoming less attractive to these indigenous plants and maybe some other crops. And maybe then we give advice to the farmers that maybe you should grow different kind of crops because you're wasting and you are not going to get back enough profits. So I think it is more, it's a long-term vision that we have, and our role now is just to see, are we getting any better results and insights from the data?
Right. Can it expect the situation in about 5, 10, 20 years? Can I give you something like a forecast about the case of the temperature distribution?
Yes. So we want to be able to do that. We want to be able to also test our models, say, with the in situ data we have, if we don't use the last 5 years of in situ data and actually see how well the models are predicting those results that we know already, and then try to see if some scenarios change, can the model give some reasonable forecasts? Yeah. So for us, it is both trying to use a very emerging technology in statistics, like functional data methods were always there in engineering, but not necessarily in statistics. So we're trying to see where we can benefit from that development and then also use it in a real scenario where maybe application is actually helping understand the system better.
Okay, thank you very much. Does anyone has any more question? Ladies and gentlemen from the attendees, they can print out their questions on the Q&A tab, and we will answer them live.
I think, Dr. Omar, you can wrap up the session to leave the participants to join the other session after 5 minutes.
Okay.
Yeah.
Thank you very much for coming, for attending. Thanks for the colleagues who presented today, for the panelists who presented, starting with Professor Das and ending with Dr. Patti. Thank you for coming, and hope to see you soon, very soon, in the Hook and in another